All right, so tonight we're going to review some couple core things you need to know and that you'll use a lot in the data science world with Python. So Pickle, Numpy, and Matplotlib or visualizations. We're going to go through a little bit of Matplot, but then I'm also going to show you another library called Plotly, which can make sometimes prettier looking graphs. So we'll kind of just go through those. I just have some things to like show you kind of as review. And then maybe like a couple like exercises for you guys to do. And then if anyone has any questions on something like they're not sure about, or something that they've seen in their project that they're trying to figure out how to do or just want some clarification on, just feel free to ask, because there's probably somebody else who has had a similar question. So we'll go ahead and start with Pickle. So Pickle is basically a way to save any kind of Python object and then recreate it later. So this is really useful for stuff that isn't already a data frame and can just be saved as a CSV. Basically, if you don't have an easy way to save it, you should just Pickle it. So the really easy way to do this, let's start by just making a list, because lists are something you might end up using Pickle for. I guess you could technically put it in a data frame, but then you'd have to turn it back into a list when you load it. So just a random list here of some scores. So we'll go ahead and run that. And then to save it, you need to open a file. So you can do file equals open. And then here we just want the name of the file. So I'm just going to call it scores.pickle, or perhaps something better would be like scoreslist.pickle. And then this next part is kind of the read-write permissions. So since we're pickling it, we're writing it to a file, we need W. And then you also need this B. It basically means it'll write it in terms of bytes. So we want to go ahead and open that file. And then with that file open, we can do pickle.dump, pass in our scores list, and then pass in the opened file. And if you look in your current folder of this notebook, you should see a scores list.pickle. So now we'll try opening it. It's basically the opposite of this. So we do file open again, scores list.pickle. And then this time we're reading it, so we need RB. So that will open the file. And then we just do pickle.load and pass in the file. And that gives us our list. So, we could just set it equal to that here. So we have to open it again. You can only run it one time, basically. And then there we have our list. So it's basically like that for any other kind of Python object. A big one you'll use if you do NLP is a tokenizer object. That's something that you almost always have to pickle. There's probably other cases, other types of objects you might want to save that you don't want to rerun again. But this is generally how you can save and load. It's pretty simple. I wouldn't mess with, it's kind of confusing. There's Python dump and then dumps, and then or pickle.load and loads. So basically, if you want to get the byte string back, you use the ones with the S. If you just want the actual, object as it is, you want the singular version. So generally, you don't need these with the S, unless you're doing something where you actually want the byte data. So I'm going to go ahead and just make a little header here. So this is Pickle.
This has been really helpful for me.
Really? Just this little part?
Yeah, just because whenever you go in the documentation, it doesn't really differentiate between load and loads. And also, there's so many different ways to, like, I was confused about how to make a pickle file in the first place. How do you do that? There's like 15 different libraries that are out there. So just knowing the process.
Yep. And then I guess the other thing, after you open a file, you probably, so we've saved to it, you probably want to do file.close. That might give you some issues. So same thing down here. We open it, we load it, and then we should make sure we close it. It just might give you some issues if you try to open it like outside of Python or other things like that.
Where's this file open thing from? Is it just a Python thing?
Yeah, this is just native Python to open a file.
Okay.
What other programs can you open it with once it's saved?
As Pickle?
Yeah.
Joblib?
You said Joblib?
Yeah.
I don't know much about that. I don't know if Pickle, let me see. Pickle, other languages maybe? I'm pretty sure it's only Python. Yeah, it's basically only going to be for Python. So you could open it, you know, in a Python editor or something else besides a notebook, but the language still has to be Python. Any questions on anything Pickle related?
Sorry, actually, so in the third line, file equals open, the scores list Pickle, you're creating the name of that document right then and there, right? Like it's okay.
Yep. So if you run open and then pass in a file name that doesn't exist, it basically makes that file.
Okay, gotcha.
And then if I didn't put anything in it, it would just be an empty file, basically.
Mm. And sorry, I think I missed this. The file dot close. You're doing that why exactly?
It's kind of just a thing because the file remains open. So like I opened it and then, let's see, file dot, like I can still read stuff off of it. Basically, Python still has it open. So if you tried to open it in other things or something else tries to access it, it won't be able to.
So you just basically have to close it each time that you use it in some way?
Yeah, yep. All right, so let's move on to some NumPy stuff. I try to just think of different things. A lot of it's with array manipulation is what you're going to see a lot. So that's what I'm going to kind of go through. And then I have some like exercise problems. And then after that, if anyone has anything else specific, we can kind of look into it together. So the first thing, let's just make a bunch of markdowns. And we'll just keep this one. Okay. So the first thing we'll do, so range of values. So to do a range of values, it's almost just like Python, but it's numpy dot arrange. And then the first value is the low end. So if we want numbers from 0 to 100, we would do 0. Second number is the high end, 100. And then the last number is the step, so the increment. So we could just do 1. And if we do, oh, we have to import NumPy first, of course. So then we get, you know, numbers from 0 to 100, but notice it's exclusive, so we'd have to do to 101, like that, to actually get 1 to 100. But you can change the step, and then you get different values. So let's try like 15. So it can be pretty useful if you need to generate a list, a range, and you are working with NumPy arrays already. So the next part is going to be a zeros array. And this is also a ones array. You do it the same way. So we'll do code. So to make an array that's basically all zeros, so to like instantiate an array and then you can add values to it, you do np.zeros. And then you can pass in a shape. So this tells it, you know, what size and how many rows, dimensions, all that I want it to be. So if I wanted, you know, 10 by 10, I could just do shape equals 10, 10. And then if I go ahead and check what that looks like, it's just all zeros.
So I have a question.
Mm-hmm.
If we need to fill it, so let's say we have a really terribly arranged data frame that's awful to work with, and we know what the shape is supposed to look like, and we need to convert to that shape. Should we start with the zeros or a ones array and fill it in?
If you know what the final shape's going to be, that's probably the better way to go. Because then you have it all there, and if as you're filling it in, you know, one of the values gets messed up or something, you still have the others. So yeah, if you always know like the output shape, it's generally better to do it this way and instantiate it. And then you can also replace this with ones, and it does what you would think it would do, and it's all ones. So then if we wanted to change a specific value in here, so modifying specific elements, we just have to do a little bit of array indexing. So if I wanted to get basically the center one, let me get these to be zeros again. So, you know, the fifth row, fifth column, I would just do X to, brackets with a 5. That selects the row. And then I want the fifth column. And then all I do is set that equal to something. So I'll set it equal to 1. And then I'll just print out the array. So that modified that specific one. I can, you know, change that up. So I could change the one to the right of it, make that a 2. So then if you had like a for loop, so let's see, it's 10 by 10. So for I in range 0 to 10, and then for j in range 0 to 10. So this would be if I wanted to, you know, fill it in iteratively. Then I could do x at I, j equals, so we'll just start a value at 0, and then we'll increment it each time. So let's make it all zeros again. And then we'll run this and see what happens. So that went through basically from the top left all the way across and down and filled in a value each time, incrementing it each time as well. So if you need to fill in an array like this, you probably just want to do this nested for loop. You just need to know how many rows and columns you have. All right, so now let's look at a 3-dimensional array. Because 2D is pretty easy to understand, but once you get higher, it gets a little more confusing. So we'll do y equals, and then this also is going to show off how you could fill in an array with random numbers. So you can do numpy.random.randint. The first value you pass in is how many, it's basically the upper end. So I think I could pass in like 0 to 100, or I can just pass in 100 if I wanted values up to 100. And then it takes a size parameter. So this is basically the dimensions of the array. So let's try doing basically a 3-dimensional array, 5 by 5 by 5. And we'll see what that looks like. So I basically have 5 arrays that are 5 by 5 each. So you could also think of this in 3D as basically being stacked behind each other, if that makes more sense. It's basically 5. It just looks like this when you print it out, but really, you know, they're all stacked together. It's kind of like a cube almost. So
quick question.
mm,
Is it better to work with the arrays? Because this is basically a list of lists, right?
yeah,
So is
kinda.
it
It's still a NumPy array though, so it has like other properties that a list doesn't have, but essentially it is nested list.
okay? So is it okay to think about them that way, or should we say not even a little bit? Because I know when it comes to like multiplying things together and adding stuff together, we're gonna have to think about it differently.
Mm-hmm. I think it's probably fine to think about it as a list in that way, as long as you realize like it's not gonna always behave like a list when you do like code things to it, if that makes sense.
Okay. Yeah.
Because like if you do type, like it's a NumPy array, so it's gonna have different properties and stuff. But in terms of structure, it's basically the same. And kind of in indexing, it's how you would think list would be if you had nested lists.
So if we start with nested lists and we need to transform them into an array to do things to them, do we just change the type?
You can usually just do NumPy array and then pass in like a list.
Okay.
All right, so indexing for this is going to be pretty similar to 2D. So we're going to do brackets. So let's say I wanted, let's say I wanted this 59. Can anybody tell me maybe how I would get that value? So I'm going to need 3 numbers.
111.
Yeah.
Yep. Good job. And yeah, you always want to remember, you know, this is index 0, because you could look at it and think, you know, oh, the second one, 222, but that would actually be like this value. Yep. So that's for 3D. If you kept going up, it would basically be the same pattern. So basically the first set of brackets is like the larger dimension. So this is, you know, 3D structure, these these groups of 5x5s. Then it is rows, and then columns is always the last one. So you can think of this as like sheets, or sheet by row by column. All right. So the next thing, let's say we wanted to get just one of these sets of 5x5s. Does anybody have an idea of how we would grab that? So let's say I wanted just this middle one.
You would just have that first indexer.
Yep. All right, let's say though now I want, let's say now I want the third row of each sheet. Does anyone have a way to?
A colon?
There's a colon involved.
Yeah, so for the first indexer, you would pass in a colon to say pull everything.
Yep, so we want all the sheets, And then the next are the rows. So what rows do we want?
The second one? Or
Yep.
2, index of 2.
And then we want all the columns. So we just put a colon. So that should be, let's see. Yep. So that's the middle row of each sheet. And then similarly, what if I want the fourth column of each sheet?
We want the fourth column.
Mm-hmm.
That would be
Do column, comma column, and 3.
Let's see. So the last one should be, yep. So that's right, but you'll notice it doesn't put it in column form. It's basically, my mic keeps like falling down for some reason. That's why I'm struggling with this. But so you notice it doesn't put it in column form, but it's put it in rows. So like this last one, 35, 27, 1, is actually here, like going down. So that's like one thing to keep in mind. All right, so now what if I want the second and third row of each sheet? So let me just print this out again so we can see it. So now I want the second and the third row of each sheet. How would I get that?
So that would be column, comma, 1, column 2, and then column.
So that only gave me one of the rows. It only gave me the second one.
You have to do 1 colon 3.
Oh,
Yep.
yeah, column 3.
So you basically, on the second one, you have to go one higher than, or no, so the first number you need to be one below, like your target start one, and then the second needs to be your target. So if we wanted the second and the third, it's from 1 to 3. If we wanted the fourth and the fifth, we would do, let's see. So we would have to do 3, and then you guys know, like you do -1, right? If you want to go to the end. So I think it would be 3 to -1. No, actually, it did not work. Let's try. Okay, 3 to 5. Yeah. So that would give us the fourth and the fifth row. Alrighty, so let's see. Now we'll talk about where. So if we want to search a Numpy array and find a certain value, which could be useful in a lot of cases, we can use numpy.where. So if we wanted to figure out where in our whole array here, the value is greater than 50, we would do y and then brackets. And then inside of here, we do np.where y is greater than 50. So this inner part basically gets us the index of all those places. And then passing that into the brackets of y will give us the actual values that are greater than 50. So that's what we get as the output. Of course, you could do, less than. You can do equals. I think it's double equals. But you get the idea. All right, so the next part is reshaping. You've seen this a lot with like neural networks, getting things in the right shape they need to be in. So let's go ahead and make a random array to start with. So we'll do numpy.random.rand int, and we'll just do values from 0 to 10, and then 100 of them. So now we have basically a one-dimensional list of 100 values. So when you call reshape on an array, you can pass in any shape that basically, if you multiply it out, it'll add up to the total number of values. So since we have 100 values, inside the shape, we could do 10 by 10, and it will basically morph it into that shape. We could do 2 by 50, 50 by 2. We could do 2 by 2 by 25. Basically any combination that when you multiply them together, it adds up to the total amount. So any combination of dimensions m, n, p, etc., that when m times n times p equals, or I guess such that total number of values. So hopefully that kind of makes sense. So if we try something that's not doable, we'll get an error, which we've probably seen this a few times before.
Few times.
Yeah, more than a few times. The other type of reshape you've probably seen is 1 minus 1.
Mhm.
So let's just remind ourselves what our array looks like. So 1 minus 1 basically makes it go in a dimension. So it basically adds brackets around what we passed in, if that makes sense. So we went from basically a one-dimensional array to a two-dimensional array. It just so happens that in the 2 dimensions, we only have, this one part, one sheet, or one, let me think how to explain that, one column, or one row, I mean.
So if I add another quote unquote sheet behind this, right? It has to be that same original shape, right?
Behind the reshaped or the base one?
The reshaped.
So if you add anything to this, you would basically have to, well, it depends how you add it. So like if you're going to do the stack method, so you just want to add like another basically row.
Yeah.
So let's do z reshaped equals that. So let's figure out how to do that. So we could make z2 equals z times 2, just to have another one. So we want to add z2 to this. So we could try, let's see. I think this is where we get into the stacking. So we want to horizontally stack maybe. So let's try mp.hstack z reshaped z2. And whenever you do a stack, the 2 arrays have to be in parentheses on the inside. So that didn't work. So let's try z.
You reshape Z2 as well?
We could, but so our z reshaped is 1 by 100. So we want to make a 2 by 100. So let's try. I think maybe append, and then axis is going to be 1. Must have the same number of dimensions.
But do we have to reshape Z2 first?
Yeah, we might have to. So let's do Z2 reshaped equals Z2 dot reshape 1 minus 1. And then we'll try passing this in. So you see what that did there? It basically added it all to the same. So really, if you had Z and you have Z2, and you basically want to put them together, I would do H stack Z, Z2. Maybe it's V stack. Yeah, there we go. So V stack will take the 2 and basically stack them vertically on top of each other. So if we started off with Z reshaped, we would basically want to just go in 1. So just get the 1 row we have, and then pass that into the V stack. And that would give us the same result. Let me just put some headers in here so it's a little less confusing. Okay, so we don't want, so this would be stack 2 arrays vertically. And then basically the 2 different options. So the other type of reshape that's similar to that is reshape. So this one was 1 minus 1, but there's also minus 1, 1, which it's easy to get these 2 flipped. But basically what this one does is adds brackets to each element inside. So now each of our values is in its own list. And so we could do the shape of this. So now the shape is 101, but our Z reshaped is 100. So it basically just flips the rows and the columns.
So like take a transpose.
You said transpose.
Uh-huh.
Let's see. So if we did our Z reshaped, yeah, so that's the same as transpose. All right, and then some more stacking. Let's go ahead and make a couple random arrays. So we'll do A equals a random array of numbers up to 10, and we just want 5 of them. And then B is going to equal the same thing. And then we can just take a look at A and B. So we just have two arrays like that, pretty simple. So if we just wanted to stack those on top of each other, we could do stack A and B. And then I'm pretty sure VStack would do the same thing since they're both already flat. Stack basically can do anything the other stacks can. It just has an axis parameter. So you can pass in the axis. VStack, HStack, and DStack all just have the axis hard-coded basically.
What is D stack?
So it would be like the third dimension. So like if we had two sheets and we wanted to stack them on top of each other.
Okay, gotcha.
My H stack looks different. It's like it looks like an append.
Really?
Mm-hmm.
On which part? On this A and B?
Yeah.
Interesting. Well, let's see, H stack, A, B.
Yeah.
Yeah, so, because that's horizontally, so it is going to be the same. The other thing that's the same as is concatenate.
Mhm.
So that will do the same thing. For one-dimensional arrays, these are all going to be fairly similar. It's only when you have higher dimensional arrays that you're going to have to, specify the axis, or they'll kind of behave differently.
Okay.
And just to show you the D stack, we can do that as well. So can we see what the D stack did here if we print these out?
Okay.
So we have the A values down this column and the B values here. And then let's go ahead and save this. So D stack, AB. So we all have seen flatten. It's pretty self-explanatory. It can take any dimension size array and basically flatten all the values. So you get one single list that's one dimensional as output. And it will just go, from left to right, top to bottom, front stack to back stack, depending on what size or shape your array is in. All right, so we're gonna do three like exercise problems. I'm just gonna put them up here and then we'll give you like 10 minutes or something just to do them. So the first one, let's see, let's add some more space here. So you're gonna need a couple arrays. So we're gonna need an M array, and that's going to be equal to random.randint from 1 to 25. And then the size is going to be 5, 4. And you're also going to need an N array. It's going to be kind of similar. except it's from 100 to 200, and the size is 1010. And the one other thing, since we're doing random, we want everybody to have the same. So we're going to do numpy.random.seed and put 4 in there. So this will make sure, even though we're doing random, everybody will have the same values. All right, so the first question is going to be, create a 6x3 array with integers from 100 to 280. And I'll keep this up on the screen. You can type it into your notebook if you want to, such that the difference between each element is 10. So that's question 1. Question 2 is using array M. Return only the values in odd rows and even columns. And then 3 is going to be using array N. Replace any value over 150 with a number that is 100 less than that value. And I'll just leave this up on the screen here, and I'll put a timer on for like 10 minutes. You guys can work on that, and I will try to figure out my microphone in the meantime.
So Matt, just to understand, we're supposed to use M and N and either stack them or transform them in a way to like for the first question, but we're supposed to use M and N arrays.
So the first one, you just make a new array.
Okay, we can make a new one.
Just for 2 you use M, and then for 3 you use N.
Okay. Thank you.
That would be an interesting challenge, though. Transform M into that array.
Yeah, that's where I was lost.
I don't think we have time for that. And when you guys finish each one, just use the annotate and put your initials next to the ones you've done, just so I know who's still working.
Annotate is so much fun, y'all.
Is it really?
Not with the mouse pad.
Oh my. I can't even make out what letters those are. We'll go like 4 or 5 more minutes. All right, Brendan and Beth have finished all 3.
Me too, but I couldn't work out how to annotate.
It should be on the toolbar at the bottom or the top of the screen. It might be on a drop-down menu, I forget. There we go.
Yeah, it's under view options.
All right, but let's go ahead and go over them, even if everyone's not completely done. So do I have a volunteer for the first one to show what they did?
Sure, I can share.
Okay.
Here. All right, so I did a range from 100 to 280 doing steps of 10. And then from there, just did a reshape to 6x3. And I get this.
Yep, that's correct. So the hint was that, you'd have 18 values doing that range with that increment, and you could just reshape it. So, yep. All right, for the second one, another volunteer.
Sure. Okay. Where's my menu? I can't see the share screen now.
It should be just at the bottom.
Ah. Maybe someone else better do this.
I wonder if I can, let's see. Spotlight video. No, I can't make you share. I guess that would be kind of bad if I could.
Who knows what you'd see?
Well, because I can stop video and, do other things, but yeah, I mean, it
hang
should
on.
just be at the
Maybe
bottom.
Yep. It was more white. Ah, man. Jeez. Why in the world? Oh, here we go. Oh.
There we go.
Okay, you see that? So I just did this guy here. So the way this works is first part is working on the rows. So you're taking all the rows from start to finish, all the columns from start to finish, and you're doing every second one. So that gets you the odd rows, 15, 10, 13. Then the next one is the same things for the columns, but this time you want to start with reference 1, which is the second column. So that'll give you this column, and put them together, and you get this.
So the odd rows and the even columns. Yep, that looks correct. Is that what everyone else got?
Yeah, but I got it completely differently.
Oh,
Do you want to
let's have a
share
look
how
at
you did it?
It's not Pythonic. So I actually iterated through. I set up a range where I would pull only the odd rows, then pull only the even rows, and then I appended them all to a list, and I turned it into an array at the end. So this would return everything flattened.
Okay. The more brute force way, but that still works. Cool. Anyone else did it a different way? All right, so the last one then. Any takers? Someone who hasn't shared? Bonnie, Jacob, Serena?
I can share.
All right, cool.
All I did here was use the where statement where it was greater than 150. and just subtracted 100 from those values and set it equal to that. And all the 150s were gone out of the end.
All right. Let me see here.
I did differently.
Mine looks a little bit different. Let me see your initial n.
Oh,
But my value is the same with Jacob's.
this is the initial n here.
That is weird.
Yeah, I had the same
Actually-
one as Jacob too.
Oh, it's because, did you all run both arrays in the same cell with m
Yes.
first? Okay, that would be why. I ran them separate and that messes with the randomness. So I have slightly different values, but that still looks correct. Yep. Cool. All right, and I actually have one more way to do the second one. You guys want to see? So here's our M array. So we want the even columns. So what you can do is actually pass in a list of the columns that you want and the rows. So we want, I mean, the even, let's see, where is it? Or odd rows.
Yeah, those are the odd rows.
Yeah. Just it's even indexes, so it throws you off. So that gets all the odd rows, and then we can just do the same thing for the columns. So we can pass in a list. We just want the first and or the second and the fourth. So that should give us the same answer then. So lots of different ways to do all things array related. Does anyone have any questions on NumPy stuff? Anything we didn't go through?
How does the indexing work, like for the colons and the commas there on your example?
So this is like above when we would, get the fifth row and the second column. So this is getting all the columns, but just these rows. And then from that, it's getting all the rows and just these columns.
Okay, thank you.
Which actually, looking at it, would this do the same thing maybe? Nope, it doesn't like that. So you do have to do it separately. Like that. All right, so let's move on then to visualizations. Let me see what I had. I had this notebook that another instructor put together. It just kind of goes through the basics. I thought we could just kind of scroll through it. And then I'll show you this Plotly library. So let's see. This is kind of about, choosing good visualizations, which is always an important part because, you have really cool data, but you still want to show it off in a way that's enticing to people to look at and to understand. So let's see if this has actually any code in it. It does not. Let's see, maybe there's... Nope, that does not have any matplot in it either. So I guess before we go into Plotly, does anybody have anything specific in Matplot that's been confusing? I wasn't really sure what to, include for this?
I know for me, I'm still having a lot of trouble with figures and axes and when to use them, when not to use them, how to put different data sets together on the same image output, how to put together graphs that look the same with different data into different graphs.
Okay, so let's go through that then.
Yeah, I agree with that. It's the X's and the figures, and you know, sometimes you can get away without using those, and then you might get into trouble when you try and resize the thing and nothing seems to work.
I'm also having trouble with like if I have multiple plots on the same figure, getting the title for the overall, like everything that's in there in the right spot.
Okay, so I just made some like fake data real quick. So let's go ahead and import it. So if we just wanted to plot like a bar graph, if you're just doing one plot, you can always just do off a PLT. Whenever you want to do multiple, that's when you have to basically get the figure and all that stuff. So I might have to refresh myself on the syntax and stuff, but you can basically do fig, comma, underscore, because you don't need the second part. I forget what it is, but and that equals plt.subplots. And then within that subplots, you can do number of rows and columns. So we'll do columns 2 and rows equals 2. So there we have, 4 graphs. And then to reference them, let me see, figure. I think we can just get the first one. Let's just look at the documentation. So we want to look up subplots. I think we actually wanted just the PLT one, this one. All right, so yeah, it takes the number of rows, and then what does it return? It returns the figure and the axes. We actually do want the axes here, because then I think we can go and get the first one, and then on that, we could plot this. I think maybe it's plot, and then in here, type equals bar, or kind. Nope, it didn't like that. So let's see if there's an example then. Yeah, so we should be able to just call plot off of that. I guess we could do it this way so that they're separated out. So then we'll have all 4. And then we can do expected 4 got 2. Interesting. Share y equals true.
You have them in brackets or parentheses.
What, this part here?
Yeah.
I think I can actually do this though, this 0, 0. There we go. So then that's how you would reference each one. So 0, 1. 1, 0. And 1, 1. Doesn't like that because it's not a NumPy array. All right, so there, if you have, if you know how many graphs you're going to need, you can kind of arrange it in a grid by choosing the columns and the rows. And then you can just reference each one off of this axis by the index, basically. And then you can do different things on each of those. I think the other important parameter here then is share y. You can set that to true. So now on each row, they actually share the same y-axis. So let's make the second one like a lot higher. Oh, I see. We need these to be NumPy arrays so that we can actually modify the values. There we go. So now they're actually all different values. So when these top two share the y-axis, you can see how that works. So both of the rows share the same y. But then I think we can also do, you can specify which ones share the y. So that's just true. We can do column. And in that case, the columns have the same y. And then we can also do row, where the rows share the same y. And then the same is true for share x, row and column. And I think we can maybe do both. So now they all should share, let's see, share y column. Okay, interesting. So basically the rows share the same y, and then the columns share the same x. So you can do a lot of interesting things like that. And then I guess you can do all as well. So if we want them all to have the same x and y axes, you can do that. So that's kind of how you do the subplots. Like I said, you only need to mess with those if you're gonna, have multiple graphs together that you want to make like a nice grid like that. Otherwise, you can just do like plt.plot. And basically, anything off of one of these axes is called almost the same as just off of plt, if that makes sense. You can think of each of these as its own PLT object for that specific region of the graph. Let's see if there's anything else in this example. The documentation honestly has a lot of good examples. So we could just look at some of those. This one shows off the error bars. But I think you all have done that when we did stats. Let's see if there's another like grouped one. Yeah, so this one actually loops through the axes and does something different on each one. So that's an option too. If you wanted to plot something and, you know, change the X or the Y range, or I don't know, do some other modification, you can do it in a loop and just loop through your axes objects.
Hey, Matt, I saw it said like set title on there. You think it's the same if you want to like put the X's on that kind of chart if you're looping through them?
If you wanted to set the X label,
Yeah, or Y label.
yeah, it would be the same. It would be ax.set X label or whatever.
Okay.
Yeah. So
Okay.
just set X
Cool.
label. Yep. There was one, a color bar, I think is what it's called.
What page is this that you're on right now?
So this was just, here, I'll go back to it. So it's just off of examples on just Matplot's main site.
Okay.
So you could basically find, you know, something similar that you're looking to do and copy what it has.
That is so much better than Googling for hours.
Yeah. So doing something like this color bar is something that like I've had to do. There's an actual color bar object you can get. And then you have to pass in an axis, I believe. And I think there's some settings you can change for like the color and the scale and the labels and all that, but that can be something cool to add. So kind of another option for visualizations that's maybe a little easier to work with is Plotly. So if you don't already have it installed, it's just pip install Plotly. You can do this version or just get the newest one, which might be this one. I don't know if you guys already have that or not. But it makes some pretty nice graphs. So if you guys want to install that real quick, I have like a quick example. So just pip install Plotly. And then we're going to import plotly.graph objects as geo for graph objects. And then we can create a list of all the months. So we'll just go through and do that real quick. So we have that list. And then it's kind of similar to Matplot. A lot of it will look almost the same. So you can do a figure and you just go off of geo.figure. And then on that, so we're basically going to make two bar charts like next to each other. So it'll be two columns. So we can do add trace and then go.bar. So we're going to do a bar plot. And then our X is going to equal our months. Our Y is going to equal, we can just do numpy.random.randint from like 0 to 25 maybe. And we want 10 of those, or 12 for each month. And the name, you can just put, you know, value 1. And then we can give it a color. So we'll just do this one as blue. So that'll kind of show the first part. And then we can actually copy that whole thing and do it again. It'll give us different values. And we'll do it as red. And if we do that, it's now stacked, which since we didn't clear the original figure, it has an extra blue one. So we actually need to run this line with the figure again so that we only get the 2. And then something else we can add, we can update the layout and change the bar mode to group. And we can change the x-axis tick angle. So basically these labels, I believe, and we can just make it that so they're like slanted. And then it's all like matplot. You can just call figure.show to view it. So there we have a pretty nice looking graph. And the cool thing is you can kind of hover over stuff and see the values. And you can actually zoom in and then double click to zoom back out. There's like some other controls here. You can download it as a PNG here. You can select things like that, highlight them, zoom in, zoom out. So I like it a little bit better than Matplot. Since it's not super familiar, you probably have to like read a little bit about it, like how to, you know, do this add trace part and that stuff, but a lot of it's going to be somewhat similar. And it just looks nicer than base Matplot. You kind of have to do a lot to Matplot to make it look really nice. You know, you have to mess with the colors and themes and all that. So this is a nice, like, out of the box, good looking visualization library. And I believe they have some examples too. Let me find. Yeah, so they have a whole bunch of examples here. Basic charts. Looks like this one actually, it was moving in the preview. I didn't know if it's actually animated. Let's see. Maybe not, but cool. Starburst plots. So I'll put this in the chat, this link, if you guys want it. But they can do, you know, 3D charts, anything you could do in Matplot, except it'll just look a little bit better. Things with maps. So if you're doing any kind of location data, this would be helpful for that. Choropleth maps. And it also does time series and all that fun stuff. So here's scientific charts. Can do contours. So yeah, pretty cool. I definitely try this for your capstone if you want to get some nicer looking graphs and stuff. So, well, do you guys have any questions on anything tonight or anything I didn't cover? That's kind of all I had planned. But if you guys have anything else that's came up.
Plotly's how you use Dash too, right? Dash is built on top of Plotly.
Yeah, it looks like it from here. I haven't actually used Dash before. Is it just like a Tableau or something?
Basically.
Yeah, so you can just make dashboard and stuff. Which that's another thing to think about using something like this or Tableau. You can make a whole dashboard with multiple plots in it. And the cool thing about this, it's web-based, so you could probably put it on your Heroku app or website.
Hey, got a link I want to share with y'all if y'all want to register for some free Tableau training they're doing due to the COVID stuff. It's like 90 days free, half off their Tableau certification if you want to add it to your resume.
That'd be awesome. Could you post that in the Slack channel, Jacob?
Yeah, I just dropped it in there.
Thanks, Jacob.
Yeah, thank you.
All right, so just thinking for next week then, I have TensorFlow, Keras neural networks, just more in depth with those, refresher. And then also more Flask and web development related stuff. So I guess for the Flask one, if you guys could maybe come up with some specific things and just post it on Slack. Maybe I'll like post a message and everyone can comment on it just so I know like what to include. But for Monday for neural networks and stuff, I think I can put together something for that. And then the following week, code outside of Jupyter, PyFile. Okay, so PyFiles, Sublime, text editor, Spider, Git, and command line. Has there been any other topics or areas that have come up that you'd like to have a review session on?
One thing for me is it's not so much a topic, but how you remember all this stuff. You know, like I get into a project and I can do everything, but it's not like it's a fluency. So it's not. I'll have to go off and Google or look at docs and just wondering what I can do to have it stick.
It's honestly, it sounds lame, but just practice doing it a bunch. You know, maybe just starting a bunch of small projects or, you know, getting a bunch of data sets, loading them in, doing all that basic stuff just over and over. And eventually, you know, you don't have to look up everything. But that's pretty normal at the beginning.
I guess that's kind of related to a question I have too. How do you plan a timeline for a project?
You mean like how do you section off like each part of it or?
Yeah, so for instance, like I have a bunch of ideas, but I can't see myself finishing in 2 months. So how do we, like what scale is a 2-month project versus a 1-week project versus spending a year on something?
So it's hard to say, like, unless you've worked on something. So the main thing to go with then is the projects that you've already done. So the capstone should probably be about twice as much effort and time and complexity as the module projects. And so if you have something that you think will take 2 months, I would suggest maybe try to come up with a 1-month version and then have that other additional work be like future work for it. So if you can find, an initial target to reach, even if you have other ones down the road, that can work too.
So follow-up question, can we take a project that we've done in the past and expand on it for our capstone?
Good question. I'm pretty sure they would frown upon that. I think they want it to be something, a data set you haven't worked with before.
So does that mean completely new APIs and everything?
I would say just different data. It could be a similar topic, but the data source has to be different.
I should have waited to do my Mod 5 project.
Are you talking about that that BioPython?
Yeah.
I mean, you could still use something from that as long as it wasn't, the chromosome thing you did.
That's the only type of data that's in there.
Gotcha. Well, you could always continue that after your capstone too.
Yep.
Because you're going to want things to do as you're job searching and all that so that you're remaining active and all that. So yeah, for the capstone, just try to pick something else and you can always come back to the other stuff. Anyone else have any capstone related questions before we call it a night? Let's see,
we have to turn in our abstract.
That is what I was about to mention. So let's see, everything's due June 19th. So if everyone could get me their abstract by next Friday, I think that would be ideal. Because then you have a little over a month for actually doing the capstone.
So I'm stuck waiting on a couple of different, because I don't know if people have rules about data mining on their site, I don't want to just go scrape everything I need. So what do we do if we're waiting for feedback from stuff like that?
So you aren't sure if you're going to be able to get it?
Yeah.
Or you just haven't? Okay. Do you know when you might hear back? So I'd say probably come up with a backup in the meantime. And then you can just submit both to me. And then we can just set a day. And if you don't have access by that day, then do the backup project.
Okay.
Yeah, because we don't want to wait and then you only have, a few weeks or something. So we'll just have to see. Anyone else? Everyone's still just searching. I know Jacob might have found something. He sent me a proposal of sorts.
Oh, yeah, I've been down a rabbit hole for about 2 weeks.
Yep. It's a struggle to choose something because it's like such a big project. You want it to be something that's right. So take your time, but not too much time. All right. Well, I think that concludes everything for tonight. So everyone have a good weekend and I'll see you next week. See ya.
Thank you.
Bye, everyone.
Bye.
Thanks, Matt.
Yep.